Hi everyone. We will move on to Young's double slit experiment. Our last lecture was about interference, and we talked about that how can we determine the change in length that can tell us about whether the interference would be constructive or destructive. We will use that to derive the equation for Young's double slit experiment. What is Young's double slit experiment? It is the name suggests that what Young's did, he had two slits which were very close apart, okay, and coherent light source. What is a coherent light source? A coherent light source is a light source, means two light sources which have same frequency and they are in phase. So how can he get a coherent source? Means, for example, he can buy two torches or two lasers and place them is exactly equal distances away from a particular screen, and then they should be in phase. But that setup would be very difficult. Instead, what he did is he had two openings, okay, and he turned on one light. He set off a light behind those two slits in such a way that it is equal distance away from both the slits. And when he turned on that light will be shining bright on those slits, and from those slits light will pass through and spread around, and diffraction would happen. Okay, so he used that principle in order to get the coherent light source. That was the first thing. But next thing, why exactly we have to do everything like this? Okay, so for example, I will start with my next slide, which will be my slide for the rest of the this section. So you can see that these are two sources, and these two sources means the first source, it is starting at this point, the first source, it is starting at this point, okay, and the second source, it is starting at this point. So you can see here that these two waves means these two slits, these two are openings, okay. So from these two openings, what is happening? Light is spreading through. These dotted lines, the orange lines, are representing the troughs, and the blue lines are representing the crests. And you can see that wherever the crests will meet, there will be constructive interference. Wherever the troughs will meet, there will be constructive interference. Wherever crest and trough will meet, there will be destructive interference. So we can figure out constructive and destructive interference in that manner. I can see that over here at this point there is constructive interference. Two troughs are meeting. Here two crests are meeting. Here two troughs are meeting. Crests are meeting, troughs are meeting, crests are meeting, troughs are meeting, which means I'm getting one straight line over here. I'm getting one straight line over here. So what I'll do is I'll put on a line here. As you can see, let's say let me make a screen first. Okay, let me make a screen first. So let's say this is my screen. Okay, so we have a screen now. Okay, you can see that the first bright spot would be at this particular exact center, at this center. Okay, what about the next one? We can figure out several over here. I can see that at this point, 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 I can make another line over here from this point. So there will be another line which will be joining all of them like in this direction, right? And then there will be another one maybe from this point, this point, this point, this point, this point, this point. So there are so many constructive interferences happening. Okay, and similarly on the other side as well. Okay, but there are destructive interferences happening as well. Wherever you can see, wherever the blue and orange lines are meeting, the destructive interference is happening. So you can see in the middle there is let me change the color first. So let me change the color. Yeah, so you can see that this point, this point, this point, this point, this point, this point. So these points are telling me that in the middle there is destructive interference happening as well. Okay, so in the middle there is destructive interference out of these, so we can make those lines. Okay, so I've just drawn all of these for you to see. So these red lines are representing all these dots. You can see the orange line and blue lines are meeting. The green dots are the constructive interference, the red dots are the destructive interference, and there is alternative pattern, which means if I see that, what I can do is I can see that, which means in the middle over here I will be seeing a bright spot. Okay, so in the middle I will be seeing a bright spot. Okay, so my wave, if I want to make a wave over here, then I would be making a wave something like this. Okay, so there will be a wave going here, then there's a peak here, and then there's a peak here, and then there's a peak here, and so on. So on the other side we will have exactly the same thing. So you see what is happening, the light intensity will be maximum here and it will keep on decreasing and decreasing. Why? Because the source is strongest in the middle and intensity on the edges is not as strong. So that's why these particular positions where the constructive interference is happening, even though constructive interference is happening, but what is happening, the light intensity is very low. Now tell me one important thing. The light coming from this point to this point and this point to this point, they have equal exact same, because this is the middle, they have equal exact same spot, or they will travel exact same distances, right? They will travel exact same distances, which means, remember in interference we talked about the path difference, and we talked about if my original two waves are in phase, the path differences at which I will get the constructive interference will be 0, pi, 2 pi, 3 pi, and so on. So this delta x at this position should be 0, right? What about at this position? It should be delta x should be equals to lambda, right? At this position it should be delta x is equals to 2 lambda. Keep in mind, what is this lambda? What is this lambda I'm talking about? It is not the distance between these 2 points. It is the distance between the path difference. Means light is traveling from this point till this point, and from this point till this point. There is a path difference between these two lines. So these lines are covering different paths. Okay, but for example, this particular line is traveling lambda more length as compared to this particular light, which is traveling from this point here, as this point is close to this particular line. And similarly on the other side it will be exact same thing. What about the destructive interference? What would be delta x over here? We know that it will be lambda over 2. This will be 3 lambda over 2, and so on. Here it will be 5 lambda over 2. Okay, just by lambda over 2 I just remembered one thing. In the previous lecture what I said is the final that I said n lambda over 2 is the multiple. No, I was wrong here. I had to do n minus 1 over 2 times lambda. That should have been the delta x. Okay, for destructive interference when the two lights are in phase. Okay, so I'm just writing it here so that you know. Now the next thing what I want to do is I want to use these distances and I want to figure out something. So why this Young's double slit experiment is important? Because the light which is coming out here, using some calculation we can figure out the wavelength of that light. Okay, because figuring out wavelength of any unknown light, that is something very crucial, and we can understand about that wave coming out. Okay, and this mechanism, this phenomena is being used in many applications to figure out the unknown wavelength of the light. Okay, whatever the wavelength is, according to that wavelength maybe some antibodies are present in abundance as compared to the others, and maybe we can figure out some drug delivery mechanism using that. Maybe we can figure out some disease mechanism using that. So there are some spectrophotometers which uses this principle. Okay, so in which figuring out the wavelength is very important, very crucial. So that is where this is very important. Okay, so so we understand this now. So we can see that whatever we learned in previous video, we are using it here. So now let's get into the derivation now. Okay, so I will get on to the next slide, and means I'll get rid of everything that we have over here, and then I will move on to the next slide. In this next slide you can see that this line is still there. What is this line? Even though we know that this is the middle line where constructive interference is happening, but this line is very important. This is our reference line which we will use to measure some angles. I want to measure at any point what would be the path length, maybe at this point. Let me change the color. So what would be the path length at this particular point traveled by the waves from this particular point of source and this particular point. So from this particular point, so we have these 2 points, right? From these 2 points, what would be the path length? Okay, in order to do that, we need to figure out the angle that we will measure will be with respect to this particular line. Okay, which means what I will do is I will make a line over here. I will make a line at this point till this point. Okay, So let me change the color of this line. So that we don't have any confusion. So let's change the color to be something. Yep, this looks good. This is fine. So what exactly this is means we need to figure out this angle. We need to figure out this angle. And why do we need it? If we can figure that out, then we will relate it with the path difference that we calculated previously and we understood previously. So we will relate this theta and this delta x, which is the path length between two waves, and we will be able to figure out whether this will be constructive point or destructive point. Okay, so we need to come up with some derivation for this particular theta, and somehow it will relate with this delta x. Okay, so this is what we need, so that we can figure out whatever that theta is. Depending on that, we can figure out whether the constructive interference would happen over there or destructive interference would happen there. Okay, and it will definitely include the wavelength of the light as well, and eventually we will have some formula for wavelength of light, and maybe some of these factors will be part of it. Okay, now what I will do is I will make the path length now. So what path length would be covered by the light wave coming from this point till this point? Okay, and what would be the path length covered by this line point to this point? Okay, so did I draw any to this point? I know these lines are not very visible. Let me change the color of these lines. Let me make the color of both of them exactly same, so that we know these are the path lengths we are talking about. Okay, so let's make their color to be green maybe. Let's do green, and we will increase their weight. Okay, so we have this. So this is showing, these two lines are showing me the path length. Okay, and light from this particular source is traveling this path, and light from this particular source is traveling this path. Okay, and in order to show the path length, the change in path length or the difference in path length, okay, what I will do is I will make another line which will join this wave in such a way that it will make a 90-degree angle at this particular point. Okay, it will make a 90-degree angle at this particular point. Why 90? How do I know this will be 90? Because we will assume that the screen in front of us is very far away from us. Which screen I'm talking about? This screen. If it is very far away from us, in that scenario this angle will be theta, and this angle will be 90-degree, and this theta and this theta will be exactly equal. If I'm talking about, for example, this particular length, if I say this particular length is L, if this L is too big, in that scenario this theta and this theta would be equal. Okay, here is this assumption that this L needs to be so big. Okay, if that is the case, then I can figure out this change in length which this particular light is traveling extra. So from this point till this point, whatever the length is from this point to this point would be equal to it, because this is the delta x we were calculating previously. So this is the delta x over here. So sounds good. And remember, the slit distance I can represent it using d. If I say that this is d, then you can see this is a right angle triangle, right? I can make this right angle triangle and I can see that this is theta, this is d. What should be delta x here? Delta x should be d sine theta, right? No? If I apply sine theta, it will be what? Delta x over d. If I cross multiply d, I will end up with this. Delta x is equals to d sine theta. So which means I can relate theta with delta x somehow now. Okay, I can relate theta with delta x somehow now. Now tell me one thing. Tell me one thing. Remember, we talked about initially, we know that both of these waves initially they were in phase. If this delta x, if this particular point is constructive interference, is a bright point, which means constructive interference would be happening, which means this delta x will be a multiple of lambda, right? For constructive. What if it is destructive? Then it would be n minus 1 over 2 times lambda, right? For destructive. If that is the case, I can substitute this over here and I will get n lambda is equals to d sine theta when we have initially waves in phase and the constructive interference is happening. What about if destructive interference is happening in the same situation? Then my equation would be n minus 1 over 2 times lambda is equals to d sine theta. What is d? D is the distance between the slits. So this is for destructive interference. Sounds good? Okay, and one important thing now. What does this n represent? Okay, what does this n represent? Any idea? This n? So I will write it here. So n is technically representing order of constructive point. What does that mean? For example, for the middle layer, the order is 0 and will be 0. For the next bright fringe, the order would be, if it is here, let's say, the order would be first order. For the next bright fringe, there will be, the order would be second order. Similarly, this would be first and this would be second, and so on. So this n is called order of constructive point. Right now I'm talking about the constructive interference. Okay, so similarly for destructive as well. So in the next video I will talk about one thing. So you see over here that, remember in the previous slide what we talked about is, we talked about the intensity in the middle is highest, then it is getting lower and lower. But can I find the distance between two consecutive bright spots exactly? No, because there is no separation. Means there is dim region, there is bright region, dim region, bright region, but there is no separation, there is no clear demarcation. And if we cannot be sure whether the middle point is here or here or here, then we cannot measure it accurately. the distance between two bright fringes. And if we can measure that, we can measure the angle well, we can measure the lambda. So everything is dependent on that. So Young's did the experiment with just two slit openings. What we are going to do is next is diffraction grating. Okay, so which will basically get rid of this drawback of two slits. In diffraction grating, we will see there will be millions of slits that we will have. Okay, not million, then thousands at least. Okay, and how they will affect this whole scenario and how they will give us accurate pinpoint location of these bright spots. If we can figure that out, we can figure out the distance between them, and that distance, if we can measure that accurately, that is really what we need. Okay, why we need, we will see that, okay, in next video.